Good morning, scholars. Today is Tuesday, March 31st, and we're about to dive into our second online math lesson. Before we jump into the math, I want to start off with just a couple of announcements. First of all, huge congratulations to everybody who was able to log into your first Google Classroom yesterday and complete yesterday's assignment. I have some shout outs for scholars who already scored a 100% that I'll be sharing in just 1 second. A couple announcements to make sure everybody knows how to find all of their materials. Every day, please make sure that you have submitted your work by 10 o'clock at night. Mrs. Dunn and I will be reviewing all of your work, and then we will let you know the following morning if you need to come to a reteach. Every day, you will need to log into your Google Classroom by 9:45 each morning to see if you have an invitation to a literature or a math reteach. You'll see an announcement on your stream. It will look like this. It might say something like, "Good morning, scholars. You have been invited for some extra help with yesterday's math lesson. Please click on this link at 10:45 this morning." If you got this link this morning, I know you went to your reteach lesson this morning. If you see this tomorrow or the next day, make sure you are also going to that reteach. You'll see the same thing for literature as well. Your literature reteach is at 10 o'clock each morning. Every day, your new lesson will be posted at noon. So around noon, make sure you're logging on to watch your ELA video and your math video. That way you can complete the work. And if you have any questions, you can come to office hours. Literature office hours are at 2:15 each day, and math office hours are at 3:15. To get to your office hours, make sure you're clicking on classwork, the day's assignment. So here's today, March 31st. Today we're turning decimals into fractions. You'll have some directions for what to do, and the fourth step will always include a link to the office hours where you can join us between 3:15 and 4:15 if you need any extra help. As always, if you have any questions, you can post them in the Google Classroom or reach out to me directly. One final reminder to make sure your lesson is completed by 10 o'clock each night and that you click the Mark as Done button. This will ensure that it's been turned in and you'll receive it back the next day with a grade. All right. Thinking back to what we did yesterday, we were working on multiplying a decimal by a whole number with a big focus on repeated addition. I want to start with a huge shout out to the following scholars who scored a 100% on their independent practice from yesterday. From UNC, can I get a drum roll, please? From UNC, we had a 100% from Jaden, Emmanuel, and Dillery. Nice work, scholars. From SCU, can I get another drum roll, please? From SCU, 100% from Ricardo, Danya, and Adam. Way to go. And from Duke, one final drum roll, please. From Duke, we had 100% from Christopher, Eulity, and Camilla. So interesting, all three classes, we had a three-way tie with 3 100% in each class. I'm really excited to see today which class wins and has the most 100%. If for any reason you did not submit yesterday's assignment, you need to pause right now and go back to yesterday, March 30th, lesson 7.1, and complete that one first. I look forward to seeing everyone's work submitted by 10 o'clock tonight. And one final piece of batch feedback, many of us who did not get a 100% got 5 out of 6. The problem we had the most trouble with, it was one of our word problems. I want us to take a look right now. Dave pays $1.75 for a school lunch on days when he doesn't bring his own lunch to school. One week, he bought a school lunch on Monday, Wednesday, Thursday, and Friday. How much did he spend on school lunch that week? The most common mistake I saw, I think, came from not a problem with multiplying or repeated addition, but just scholars who were not reading the question really carefully. I want to first ask myself, well, how much does one school lunch cost? And I see that one school lunch costs $1.75. Then I want to ask myself, well, how many days did Dave buy a lunch? He bought a lunch on Monday, Wednesday, Thursday, and Friday for a total of 4 days. So let's just pause and ask ourselves, what multiplication sentence matches this problem? And yes, the multiplication sentence that matches this problem is 1 and 75 hundredths times 4, because he bought his lunch Monday, Wednesday, Thursday, and Friday. I am so confident that once you have the multiplication equation written, we would have been able to solve that one correctly. Today we'll have some more practice with some word problems so we can really focus on reading them carefully so we can put all of our great strategies into action. All right, we are ready to begin. All right, so lesson 7.2. Today we are going to be focusing still on multiplying a decimal by a whole number, but today we have a big focus on how can we turn our decimal into a fraction. You may love this strategy. This may not be the strategy for you. Everyone's going to try it today, and as always, you are welcome to always double check using a second strategy. All right, please follow along as I read the story. As a quick reminder, you do need blank paper to solve the problems, as well as a pencil. If you do not already have those materials out, take 1 second to go get those. Pause the video if you need to, and then restart it once you have your materials. All right. So one of the most fun sports to watch in the Winter Olympics is a sport called ice sledding. It's not a sport we get to do a ton here in Phoenix, but if you've ever seen it, it is really fun and really fast. In ice sledding, a team all gets in one sled. They start at the top of a really big hill, and then when they say, take your mark, get set, go, they rush in the sled so fast down the ice. If you have ever stepped on ice or been ice skating, you know how slippery and fast the ice is. So you can just imagine how fast this sled is going when they're ice sledding. So before the Olympics, the ice sledding team is practicing. They want to practice to make sure they are really fast. So this team, once they start their sled down that big hill, it takes them 87 and 436 thousandths of a second to complete the track, to get all the way around. They practice every day in a row for 3 days. So we want to figure out if it takes them 87 and 436 thousandths of a second to make it around the track, and they do that 3 days in a row, how many seconds did they sled in total? I am going to give you 2.5 minutes to solve this problem. Remember to estimate your answer first. Your choice of strategy, you can use repeated addition, you can turn your decimal into a fraction, you can use the standard algorithm, you can use partial products, whatever you like. Make sure that if you finish solving it, you check your answer with your estimate and make sure it's reasonable. If you finish solving it one way and there's still some time left, of course, begin solving it a second way. All right, scholars, 2 minutes, 30 seconds on the clock. Happy solving. Go ahead and get to work. All right, we're down to about 1 minute. Make sure that you're checking your answer against your estimate to make sure it's reasonable. And if you've already solved it one way, go ahead and try it that second way. All right, time's up. Go ahead and put your pencils down. Your eyes should be right up here. Let's take a look at what some of our scholars did. Let's start by actually writing the multiplication equation that matches this story. I see we all identified this as asking 87 and 436 thousandths times 3. The first thing I want to do is I want to estimate. So I know that this is about the same as about 87. I got that by just rounding to the nearest whole number times 3. In order for me to solve this, I can do 80 times 3, which is 240. 7 times 3 is 21. And so I know that the ice sledders were sledding for about 261 seconds. This is going to be really helpful once I have my answers to check and make sure, are my answers reasonable? So let's take a look at some of the different ways I saw you solving. Let's start with repeated addition, something we became really good at yesterday. This problem is a great one to use repeated addition because I only need to add my decimal 3 times. If I had something, if they had done their practice like 35 times, that would be a lot of repeated addition, but this seems like a great problem to start with repeated addition. If you already solved using repeated addition, that's great. I want you to just check what you have with what I have. If you did not already solve it using repeated addition, I want you to find some room on your paper to solve it that way right now. So let's set it up. 87 and 436 thousandths. I want to make sure I'm keeping all my decimal places nice and neat, my tenths, my hundredths, my thousandths. And I'm going to line it up, and they only went around the track 3 times. If you did not already solve this, make sure you're adding this on your paper, and let's see what we get. All right, I got to an answer of 262 and 308 thousandths of a second. I want to compare this to my estimate. I know it was going to be around 261 seconds. This is pretty close. I can tell that my answer is reasonable. If you also got 262 and 308 thousandths, nice work. Air high five. Get ready. All right, let's try it another way. I saw several scholars solving it. I saw several scholars today who were trying the standard algorithm. Pretty exciting stuff. Please find some room on your paper. If you already solved it this way, that's great. You can check in to make sure that what you have matches what we have. If not, I want you to find some room to solve it now. I'm going to set it up as 87 and 436 thousandths times 3. Now I'm remembering that when I want to multiply using the standard algorithm with a decimal, I can temporarily take my decimal out. And this is actually going to be the same as 87,436 times 3. And then I just have to remember to add my decimal back in. So I temporarily took it out. I'm going to solve, and then I'm going to put my decimal right back in. We all know how to solve a problem like this using the standard algorithm. Go ahead and solve it on your paper as I solve it on mine, and we'll check in to see what we got. All right, so I got to an answer of 262,308. Yowza, that's a lot of time. But wait a second, when I compare it to my estimate of 261 seconds, that's not very close. This is not a reasonable answer. And so I remember, oh yeah, I temporarily took out my decimal points. I need to put it back in. I know I need an answer that's pretty close to 261. I also know that I had 1, 2, 3 digits after my decimal point. So I'm going to need to move my decimal point 3 times. Once I do that, and I have an answer of 262,308 thousandths, I realize that's very close to my estimate. And I also realize it matches exactly my answer with repeated addition. Nice work. If you solved using the standard algorithm and you got to this correct answer, excellent job. Give yourself a self high five. Get ready. All right. One final way I want us to try solving today. I saw a few scholars, Miguel Angel, I know this is your most favorite way of solving decimal problems. A few of you also really appreciate turning your decimals into fractions. Please find some room on your paper if you did not already solve this way. We're all going to try solving it this way right now. So I know my original problem was 87 and 436 thousandths times 3. I can just rewrite this as a fraction because we are experts at multiplying fractions. The nice thing about writing a decimal as a fraction is when I say it out loud, it tells me exactly the fraction I need to write. 87 and 436 thousandths. And so I know my denominator is, I know my denominator is going to be 1,000 because when I say it, I'm saying 436 thousandths times 3. Now, I already know how to multiply a fraction. I know that I can use partial products to multiply each piece of my mixed number with my whole number. But one way to really keep track of our work is let's just set up an array. If you didn't do this on your paper, I want everyone to try this now. Just like we used to do all the time when we were first learning how to multiply, I'm going to set up my array. And I'm going to put one piece of my 87 436 thousandths. So I know I need to multiply by 80. I need to multiply by 7. And I need to multiply by 436 thousandths. Make sure your paper is set up like mine. And I'm multiplying each one of these by 3. All right, now we know exactly what to do. I'm going to start right here on the left, and I'm going to multiply my 3 times 80, which I know is 240. I'm going to multiply 3 times 7, which gives me a product of 21. And then I need to multiply 3 times 436 thousandths. Okay, I'm remembering how to multiply fractions. I know I multiply my numerators together and then my denominators together. I also know that 3 just has a denominator of 1. So for me to solve 3 times 436 thousandths, I need to do 3 times 436, and then I need to do 1 times 1,000, but that's easy breezy math. I already know that that's 1,000. I don't know 436 times 3 off the top of my head. I'm just going to use the standard algorithm to solve that really quickly. 436 times 3. I could also use repeated addition. I could also use partial products. I'm just going to solve it using the standard algorithm. And when I do that, I get 1,308. Now, I can't forget my denominator. We knew that 3 was the same as 3 over 1. 1 times 1,000 is 1,000. So when I multiplied 3 times 436 over 1,000, we got to an answer of 1,308 over 1,000. I can reduce this, though, to make it a little bit easier on myself. I know I can take out 1,000 thousandths, which is a whole, and that leaves me with 308 thousandths. I'm just going to write that in my box right here. All right, just like always with an array, now that I have each partial product, I knew 3 times 80, 3 times 71, and 3 times 436 thousandths. I'm now ready to add them up. I'm going to start with 240 plus 21, which gives me 261. And now I can add in my 1 and 308 thousandths to give me a grand total of 262 and 308 thousandths. Let's check that answer. Is that the same thing we got when we used our standard algorithm? It is. And it's the same thing we got when we used repeated addition. It looks a little bit different, but it even sounds exactly the same. 262 and 308 thousandths. 262 and 308 thousandths. I did it. Nice work. Everybody was doing some additional work on this fraction one right here. Nice work. Let's add a beautiful smiley face to our paper. Grab a pen or a marker if you have one. It just makes it more fun. That was a lot of hard work. So today, scholars, we're going to continue practicing multiplying a decimal by a whole number. You may already have a favorite strategy for doing this. You may have a strategy that works when the numbers are a certain size, but doesn't work as well when the numbers are a different size. Today, we're just going to be exploring with more strategies. We're all going to try the fractions because it's a great thing to know how to do. If you're Miguel Angel and you love this strategy and you want to use this all the time, that's great. If you are thinking, you know what, this is not my favorite strategy, I actually prefer repeated addition or the standard algorithm, that's great too. It's really up to you, but we just want to make sure we know how to use all of them. All right, let's take a look at some more problems. All right, in our next problem, we have an art teacher. Our art teacher decides that she needs to buy some more. The art teacher decides that he needs to buy some more paint for the classroom. So he buys some red paint. The red paint is $15.62. He also needs blue paint, and he needs a little bit more blue paint than red paint. So he actually spends 3 times as much for the blue paint than he did for the red paint. And we want to figure out how much did this blue paint cost? Let's start by just writing the number sentence that matches the story. On my paper, I ran out of room, so I'm going to go ahead and flip it over so I have a fresh sheet of paper with plenty of room to solve. On your fresh sheet of paper, go ahead and write the equation that matches the story. You can check in to see if yours matches mine. I know this is asking me to solve 15 and 62/100 times 3. All right, I always want to remember to make my estimate. So as we estimate, I just like to round my decimal to the nearest whole number. I know that 15 and 62/100, I can round that up to 16 times 3. Go ahead and complete your estimate. All right, so we're going to be looking for an answer around 48. This art teacher spent about $48 on his blue paint. They must be doing a project with lots of blue paint. I'm excited to see what it is. So let's now solve this problem. I'm noticing that I have a decimal and I only need to multiply it 3 times. This could be a great time for me to try repeated addition. I also could try using the standard algorithm if I'm feeling comfortable with that. Pick one of those ways you want to try it, and then we're all going to try it using the fractions as well. Go ahead and solve it either using repeated addition or the standard algorithm, or both if you have time, and then we'll check in and see what we got. All right, take about 20 more seconds. All right. When I solved it using repeated addition and when I solved it using the standard algorithm, I got the same answer. I got $46.86. That matches. It's also very close to my estimate. We said he was going to be spending about $48 on his paint, so this matches. Great. If you also got $46.86, whichever strategy that you use, give me a big thumbs up. Nice work. That looks like just about everybody. All right, now I want us to all try it using fractions. So the first thing I want to do is I want to convert my decimal into a fraction. I know that 15 and 62/100 can be written as 15 and 62/100 times 3. All right, let's set up our array so we can multiply. I'm going to put each piece of my 15 and 62/100 And I know I'm multiplying by 3. Go ahead and try this on your own, setting up your array. Then you can check in to see if it matches mine. All right, check in to see if your array matches mine. Great. Now we're ready to multiply. 3 times 10, easy breezy. I already know that. 3 times 5, another easy breezy. Now 3 times 62 hundredths. I'm remembering that I need to multiply my numerators. The denominator in 3 is just 1, so my denominator of 100 will stay the same. I need to make sure I know what 3 times 62 is. If I'm not sure, I can just solve it really quickly on the side of my paper. And so I know that 3 times 62 hundredths is the same as 186 over 100. Now I can also reduce that fraction. I can take out my 100 hundredths and I can make this 1 and 86 hundredths. All right, now I'm ready to add them up. On your own, I want you to add up your products. I'm gonna add up mine and we'll see what we get. All right, once you have your sum, make sure you check it. Does it match what we got when we multiplied using our standard algorithm and our repeated addition? It does. We still got 46 and 86 hundredths. Pretty cool stuff. Whether we multiply as a decimal or as a fraction, it came out to be exactly the same. All right, another one to try. All right, no word problem here. Here, just a straight up multiplication sentence, a few more digits. I want you to try this one on your own. You need to try at least, or you need to try the fraction method, and then you need to try at least one other way. I'm gonna give you, we'll do 3 minutes of work time and then check in. You must have the fraction method, and then you need to also have one other way. I'll be solving it as well, so if you get really stuck, just peek right up here to see what I'm doing, but I want to challenge you to try it on your own. All right, find some room on your paper. 3 minutes of work time is on the clock. Go ahead. Scholars, we forgot to estimate. I am so sorry. Let's pause where we are with our answer and let's make sure we've done a quick estimate of 93 and 215 thousandths times 4. Make sure you have that at the top of your page. I bet some of you got that even though I completely forgot. forgot. I got an estimate of about 372. I know you did too. Let's go back to work solving. I won't ever let that happen again. All right, I'm going to add 2 more minutes of work time to make sure everyone has time to finish solving it, both using repeated addition and standard algorithm, or standard algorithm and the fraction method. Again, if you get stuck, you can check up here, but I want you to try this on your own. 2 more minutes, go ahead and get back to work. All right, final 5 seconds. All right. Let's check in. See if what you have matches what I have. I solved using repeated addition. This was a nice choice for repeated addition because I only had to add it 4 times. When I added that all up, I got 372 and 860 thousandths, which is very, very close to my estimate. I got the same thing when I solved using the standard algorithm. Take a quick look whether you used repeated addition or the standard algorithm. If you got to that same answer, go ahead and give yourself a check. Nice work. Next, we all tried doing this using fractions. I converted my 93 and 215 thousandths into 93 and 215 thousandths to multiply it by 4. I set up my array. I multiplied 4 times 90, 4 times 3, and 4 times 215 thousandths. For me to solve 4 times 215, I just did a quick standard algorithm on the side. Since this was only 860 thousandths, I didn't even have to reduce it. When I added 360 plus 12 plus 860 thousandths, I got to an answer of 372 and 860 thousandths, which matches exactly what I got in my other two strategies. Nice work. If you were able to solve this correctly using fractions, that is very impressive. We're going to give ourselves a big old smiley face, and this time he needs to be wearing a hat. Finish up your hat-wearing smiley face. Nice job. We are now going to go into some practice that you get to try some problems on your own. I want everybody to try the fraction method. It does not have to be your favorite strategy. If you are thinking, man, turning my decimals into fractions is more work for me or harder for me than using repeated addition or the standard algorithm, that's okay. You get to pick your strategy. But today I want you to at least try the fractions, and then you can try it one other way to check your work. Don't forget to find your estimate before you begin solving. This is always just such a great clue that you're on the right track. All right, I am out of blank paper. I need to grab myself another piece. You may need to grab yourself another piece too. Let's get ourselves set up. All right, scholars, only 2 problems to try right now. One thing I'm just noticing as I read this very first problem about Jacqueline. Jacqueline bought juice boxes to give to her softball team. The juice boxes cost 81 cents each, and she bought 21 boxes. How much did Jacqueline pay for the juice boxes? When I see a number like this, 21, that big, I'm thinking I probably don't want to do repeated addition. 81 cents times 21, or added up 21 times, is just a lot. So I'm thinking I want to try my fractions. Maybe I want to try standard algorithm, or maybe I can think of another way to add 81 cents or to break up my 21. So maybe I'm multiplying by 10, so I don't have to add it up 21 times. 2 problems. We'll start off with Jacqueline, and then I'll scroll down after a couple minutes so you have plenty of time. We'll start with 5 minutes of work time and check in and see if we need any more. Don't forget to also try your fraction method. Go ahead and get to work. Don't forget to make your estimate before you begin solving. So as I'm thinking about my very first problem, I've set up my multiplication sentence, and I've already come up with my estimate. Make sure you have that on your paper as well. All right, I am going to scroll down so you can see the next problem. This one is multiple choice. Again, trying to solve it in at least two ways. Don't forget to do your estimate. All right, 30 more seconds. Final 10 seconds. Make sure you pick the letter that matches the choice that matches what you got. All right, and we'll stop right there. Let's quickly check in and see what we got. For problem number one, if we set it up, I decided I did not want to use repeated addition to add something 21 times. Now, when I did my estimate, I rounded 81 to the nearest whole number, which was 1. So I knew I was looking for an answer around 21. I knew it would be a little bit less than 21, but it shouldn't be 2 and it shouldn't be 210. I took out my decimal in order to multiply using the standard algorithm. When I was done solving, I was able to put my decimal back in the two places I took it out, knowing I was looking for an answer a little less than 21. 170 would be way too big, and 1 would be way too small, so I knew my answer was $17.01. I then tried it using my fractions. Now, here, it was pretty easy. I didn't even need an array. I knew that 81 hundredths as a fraction would just be written as 81 hundredths. To multiply by 21, I already knew 81 times 21 was 1,701. I knew my denominator of 100 would stay the same. And then I could reduce this to 17 and 100. Same exact answer both times. Nice work. If you solved correctly today using either repeated addition or the standard algorithm, I want you to give yourself one check. And then if you solved correctly using fractions, I want you to give yourself another check. Also give yourself a check if you remembered to estimate. All right, let's take a look at number 2. Here we were multiplying 12 times 66 hundredths. For my estimate, I rounded 66 hundredths to the nearest whole number, which was 1. I got an answer of 12. I knew it wouldn't be all the way to 12. I knew it would be less than 12, but it shouldn't be 1 and it shouldn't be 120. First, I solved using the standard algorithm. Again, I took out my decimal point to multiply 12 times 66, and I got an answer of 792. When I went back to add in, I knew it couldn't be 79. I knew it couldn't be 792 thousandths, so I knew my decimal point was going to have to move those two places where I'd taken it out. This got me to an answer of $7.92. When I checked in with my multiple choice, that was choice C, so I knew I was on the right track. Then I solved it using fractions. Here, I had 12 times 66 hundredths. I just turned my 66 hundredths as a decimal into 66 hundredths as a fraction. I already knew 12 times 66 was 792. My denominator, 100, just being multiplied by 1, stayed the same. To reduce it, I took out those 700 hundredths, which was 7, and I got to an answer of 7 and 92 hundredths. It matched what I got before. If you solve this one correctly using either a standard algorithm or repeated addition and got C, give yourself a check. And if you did it correctly using fractions, give yourself another check. And if you remember to estimate, give yourself a third check. All right, count up the checks you got today. It was a total of 6. I always like to give myself a score with bubble numbers because they're just really fun. I got a 6 out of 6. You can give yourself a bubble number score that matches what you got today. And I'm going to decorate mine with stripes. All right. Nice work today, scholars. Today we continue to work on multiplying a decimal by a whole number. We tried some new strategies. You may still be thinking that you have a favorite strategy, and that's great. You're welcome to use whichever strategy works successfully for you. What you will be working on now is your independent practice. You will need to go back into your Google Classroom and click on today's assignment, March 31st, 7.2, decimals to fractions. There's some directions for you. You've already watched the video, and then you will click on today's practice. When you open it up, you will see your problems. Each one reminds you to not forget to estimate first. Quick point, if you are typing in a fraction, you will be using the slash symbol. So if for number 1, let's just say my answer was 2 1/2, that's not really the right answer. I would type in 2 space 1/2. And we would read that as 2 1/2. That's if you chose to use fractions and you want to put in your answer with fractions. Nobody put the answer of 2 1/2. It's not correct. When you are done, make sure that you click submit and then make sure you indicate that your lesson is done. So you will click mark as done. Tomorrow you'll get some feedback on your work. Yesterday, we had 3 scholars in UNC, 3 scholars in SCU, and 3 scholars in Duke score 100%. I cannot wait to see how many 100% we get today and which class has the most. If you have any questions today as you're working, make sure you're coming to office hours at 3:15 by clicking on this link for some extra help. Tomorrow morning, you'll check in to see who is being invited to reteach. All right, scholars, happy solving.